Welcome. In this video, we are going to look at the quadratic formula. So the quadratic formula is another way to solve quadratics, particularly if our factoring does not work or we can't use square roots. So it is a method that works with all quadratics to solve them, but it has a lot of moving pieces. So if we have our quadratic formula in standard form, this should look familiar, ax squared plus bx plus c equals 0. You can use the quadratic formula to find x. So this is the quadratic formula right here, that x is equal to negative b, so we're going to take that b value, plus or minus the square root of b squared, so again that b value, minus 4 times the a value times the c value, all divided by 2a. So it's a lot to remember. So I'm going to give you a little handy tool here to remember that. Let me switch over here. Okay, so here is our tool that hopefully will help you remember this. Let's try that one more time. Okay, so hopefully that'll get stuck in your head and will help you remember what the quadratic formula song is, or what the quadratic formula is. So let's go back to how can we use this. So let's get switched back over here. Okay, so if we are going to use the quadratic formula, we first need to make sure it's in standard form. So once we're in standard form, ax squared plus bx plus c, identify what is a, what is b, and what is c. All right, so a is what you're multiplying your x squared term by, b is what you are multiplying your x term by, and c is your constant at the end, making sure you keep the signs with them. They're really important. Okay, then we're just plugging them in. So x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, oops, that's a 4, all over 2a. And now our task is just to simplify this expression here. So we're going to do everything inside that radical first. That is a grouping symbol. So if you want to, you could do this by hand, or you can type that whole thing into your calculator that's under the square root symbol of 5 squared minus 4 times 6 times negative 4. And we'll get 121 in this case. So now this is negative 5 plus or minus the square root of 121 over 2 times 6 is 12. Okay, then we just keep simplifying from there. So using our simplifying for radicals, 121 is a perfect square, so that's 11. So this is negative 5 plus or minus 11 over 12. So then our two answers are negative 5 plus 11, which is 6 over 12, which is 1/2, or negative 5 minus 11, which is negative 16 over 12, which is what, 4 4/3. So our two answers are x equals 1/2 or negative 4/3. And just like all of our problems with quadratics before, always a great idea to just check. So if you type that back into your original equation, it should work to get 0. And if we try our other one, oops, Put -4/3 in there. Let's try that again. -4/3. We should get 0 as well. Okay, so always a great idea to check your answer. I'm a little more complicated when I put a radical in there, but you still can use your calculator to check it. Okay, so let's try a couple more here. So first thing, we need to be in standard form. This is not in standard form, so I'm going to subtract p from both sides and subtract 20 from both sides. So I get p squared minus p minus 20. Don't forget, I can always put a 1 out here. So that's a little clearer what a, b, and c are. So a equals 0. A is 1, b is -1, and c is -20. So then we're just using our quadratic formula. X equals -1, so that's 1 plus or minus the square root of -1 squared minus 4 times 1 times -20 all over 2 times 1. Okay, so again, I would just put this whole thing in your calculator. Make sure you put that b squared in parentheses minus 4 times 1 times -20. And so we get 1 plus or minus the square root of 81 over 2. Okay, 81 is a perfect square, so we get 1 plus or minus 9 over 2. So 1 plus 9 is 10. 10 divided by 2 is 5. And 1 minus 9 is -8. -8 divided by 2 is -4. So we get 5 and -4 for our solutions there. Okay, another example here. Where I start here with x squared minus 3x equals 7, almost in standard form, but not quite. So you just need to subtract 7 from both sides to get that on its own. So now I have x squared minus 3x minus 7 equals 0. So a is 1, b is -3, c is -7. So negative b is 3 plus or minus the square root b squared minus 4 times a times c all over 2a. Okay, I'm going to just put that in my calculator. -3 squared minus 4 times 1 times -7. We get 37. So 3 plus or minus the square root of 37 over 2. Okay, 37 is not a perfect square. Does it have any perfect square factors? Let's see, 37 might be prime. Divided by 3, 5, 7, 9, 11, 13, 15. Yeah, 37 is prime. So we're just going to leave it right there. And that is our 2 answers. All right, if I wanted to find the decimal answers, I just do 3 plus the square root of 37 divided by 2. And 3 minus the square root of 37 divided by 2. So we get 4, oh, you can't see that, 4.54 and -1.54 approximately. Not exact answers because 37 is not a perfect square. So let's just take a look at where the quadratic formula is most challenging is really just in simplifying our solutions once we get all those things plugged in. So I don't think we really have that many issues with actually simplifying under the radical because you can use your calculator, just type that whole thing in. As long as you put parentheses around your b when you square it, then most of us can do that pretty easily. The difficult part is once we get here, what do we do? So we're still going to use our properties of radicals. I cannot divide your 4 and 2 because 4 is not being multiplied. Division does not undo addition and subtraction. It has to be a factor of the numerator in order to divide it out. But I can look at 28 and say 28 is 2 times 14. 14 is 2 times 7. So that simplifies to 4 plus or minus 2 root 7 over 2. Now, 2 is a factor of all of my things here, so I can divide out a 2 and say that this is 2 plus or minus the square root of 7. Means all of these things have a factor of 2. Okay, 6 plus root 12, so 12 is 4 times 3. Ooh, 4 is a perfect square. Square root of 4 is 2. So this is 6 plus or minus 2 root 3 over 4. These aren't all divisible by 4, but they are all divisible by 2. So I can divide out a 2 since it's in all 3 of these places. So we get 3 plus or minus root 3 over 2 when you divide a 2 out of all of those pieces. Okay, let's try another one here. We have negative 8 plus or minus the square root of 80. So I'm going to make 80 into 4 and 20. 20 is 4 and 5. Oh, there's a pair of 4s. So I'm going to have negative 8 plus or minus 4 root 5 over negative 6. Okay, and then I'm looking at all 3 of these values. They all have a factor of 2. So 8 divided by 2 is 4. 4 divided by 2 is 2. And 6 divided by 2 is 3. We could leave it there. You might also see this as 4 plus or minus 2 root 5 over 3, because if I change all of the signs, I'll get the same thing. So either one of those is an acceptable answer there. Okay, negative. Uh-oh. If you see that right away, no real solution. I can't break down the square root of negative 15 because nothing times itself equals a negative number. No real number times itself equals a negative number. Okay, last one here. 12 is 2 and 6. 6 is 2 and 3, pair of 2s. So we have 6 plus or minus 2 root 3 over 4. Look at all of your terms. 6, 2 root 3, 4. They all have a factor of 2. So we can divide that 2 out and we'll get 3 plus or minus root 3 over 2. I feel like we did this exact same one twice. That's because we did. It was number 8 and number 5. So hopefully that one you are very, very good at, and really take your time to practice that. Make sure you're only dividing out factors and not terms themselves. So that is all I have for you. Thanks so much for watching.